All right, welcome in for our final video here on combinational circuits for organ arc. We just did multiplexer, which is choosing which of two inputs to route to output. It's worth noting, although this is not heavily used in our project, that there's such a thing as a demultiplexer, which is basically undoing what we just did. And the idea here is that you take one input, let's call it A this time. Again, I think in most of the project, when we use multiplexers and demultiplexers, I'm using A and B. So let's use that here. I'm going to use just A, because now the idea of a demultiplexer is that we have an input A, and we're choosing which of two outputs it will affect. All right, so if A is 0, then maybe we want out 0 to be 0. If A is 1, maybe we want out 0 to be 1. But we get to choose which of our outputs we want. So I'm going to do the same thing where I have a select, I have an A pin for input, and I have a select pin that lets me choose which output A goes to. So if A is 0, then I would want out 0 to be 0. If A is 0 and select is 1, I'd want out 1 to be 1. So we need an out 0 and an out 1. So let's do out 0 with a label. And then I'm going to highlight, copy and paste, and we'll do that as out 1. So the idea here is that if select is 0, then whatever A is reflects on out 0, and if select is 1, then whatever happens to A is reflected on out 1. And so I'm actually going to drag the select over a little bit, give myself a little extra space here. So whatever A is should go to out 0 if select is 0. So we could think of out 0 as an A. So again, whatever A is, and I want it to happen when select is a 0. And so hopefully we're starting to recognize at this point that means we need a NOT gate for my select. Because if select is 0, I want this AND gate to turn on and match whatever A is. So if select is 0, then whatever comes out of this AND gate should reflect whatever A is. So if select is 0 and A is 0, out is 0. And if select is 0 and A is 1, out is 1. So again, we're selecting, we're choosing, we're sort of demultiplexing. If we have an input, one input, we can route it to two separate outputs. So it's our ability to demultiplex. On the other hand, if my select bit is a 1, then I want my AND gate down here to reflect whatever A is. I'm actually going to shift this back a little bit to make sure there's no overlap there. So now whatever A is should go to out 1. So I'm going to line A up with the rest of my A's, keep my A circuit on its own little area, and then we'll go ahead and route this over to out 1. Let me move out 1 over here maybe. There we go. So if select is 0, then A will affect out 0, and out 1 will just be left at 0. If select is 1, then A only affects out 1. Right? So there you go. So that's the idea of a demultiplexer. Is take one input and route it to potentially two different outputs. Again, truth table for this would work great. It's probably a good place to start and think about this as well. And so start with what should my circuit do, and then how can I build it. So I'm going to go ahead and highlight all this, create my integrated circuit. Oh, and I didn't label something. SEL. Oh, I didn't label A switch as A. Oh, and this should be out 1. I did a very poor job labeling this time. So there we go. Went back and labeled everything. That's the kind of error you get in your integrated circuit if you didn't label anything. And again, we're going to follow that pattern of putting the select pin on top. And we'll call this a DMux for a demultiplexer. This is usually how it's written. So there we go. So at the end of all this, we have built ourselves a half adder, a full adder, a 2 to 4 decoder, a demultiplexer, and a multiplexer, where multiplexer is shortened to mux. That's what people prefer. So that's it. These are all the ideas behind combinational circuits. And what you'll find on the project is that several of these you'll use to help create your ALU So you'll build off of these. So if you have a question about any of these, feel free to refer back to the videos and create your integrated circuits. We'll talk more about it in class on Monday.